Hi, this is the final project for IE413 by Group 5. In this project, we will be simulating a tennis game called Dingle. Dingle is a tennis game invented and played by the Korean Tennis Club for when the number of players far exceeds the number of available courts. Due to how it is played, we modeled it as a variation of a queuing problem. The game begins with two kings on one side of the court and multiple challengers on the other side in two evenly sized queues. At the start of each game, a challenger from each of the queues becomes a challenger pair and plays against the king pair while the rest of the challengers in queue wait. The goal of the challengers is to become the new king pair, while that of the kings is to maintain their status. A Dingle game is begun as two half-court singles between each challenger pair. At the first point scored by any of the four players, both single matches end and Dingle is announced. The game immediately switches to a double between the king and challenger pairs. A pair who wins this double gets a point, and a challenger must win 2 points in a row to become the new king pair. If this happens, the previous king pair goes to the challenger queue. If the challengers lost a point at any time during the doubles, they return to the challenger queue. It should be noted that the points scored in the singles is not factored into the 2 points required for becoming kings. It is only used to signal the end of the singles phase of the game and the beginning of the doubles phase. Some additional details to note for the scope of our project objectives are playing time and additional king pairs. Playing time is random but depends on player level, ranging from A, the highest level, to C, the lowest level. Matches between an A-level player and a C-level player tend to be short, while matches between two evenly matched players tend to be the longest. An additional king pair may be selected from the challengers when there are many players. The two king pairs then switch off every 3 games. If a king pair loses to a challenger pair, the standby king pair immediately begins play, while the victorious challenger pair becomes the new standby king pair. The defeated king players go back to the challenger queue. It is believed by the members of the Korean Tennis Club that the waiting time is very long, providing motivation for members to aim for the king position, as kings enjoy more playing time. Members also feel that kings tend to play more points when an additional king pair is present. By simulating the Dingle game, we would like to obtain answers to the following questions. 1. What is the average waiting time for a challenger to play a game? And 2. Does the presence of an additional king pair have any effect on the average number of games or points one can play as a king? And if so, how much? The following assumptions are applied to the simulation. A point refers to a basic unit of Dingle play, namely one transition from singles to doubles. A game consists of a set of points played by a distinct challenger pair. The game ends when a king pair wins a point or a challenger pair wins 2 points. The waiting time is defined as time spent in the queue. The probability of winning is assumed to be the same for all players throughout the round. Though this makes the model less realistic, it allows us to clearly observe the effect of an additional king pair on the average points played, since it disregards player ability. The average waiting time for challengers is also not affected by who wins.
In our model description, we will briefly talk about the entities that appear in our simulation, and then we will run through the event graph. First, let's describe our entities and enumerate their attributes. Our model encompasses 4 physical and permanent entities: the challengers, the kings, the queues, and the additional kings. The challengers and kings can both have 3 different levels, and the chances of winning are 50% for each. The queues have a size that ranges from 6 to 12 people, and after the beginning of a trial, the size stays the same until the end of the trial. The additional kings are similar to the kings and challengers in the sense that they can also have 3 different levels, and their chances of winning are still at 50%. Now let's move on to the event graph and run through the scheduling mechanism behind it. In the initial event, the length of each of the 2 queues is determined, thus yielding the total number of players, followed by choosing the first pair of kings. Moving on to the next 3 events that can be scheduled, we have add pair, which selects an additional pair of kings if there's 16 or more players before scheduling the start 2 event, start 1 when the total number of players is under 16, or stop if the delay from the initial event has reached 1,680 seconds or 28 minutes. This event also cancels the start of a new game, but does not stop the games that are currently in progress. In the case when start 1 is scheduled, there are two possible events to be scheduled right after. Either kings win with a probability of 50% and the game restarts immediately, or the challengers win their first point with the same probability. Both events have a delay depending on the matchup of the players. The closer in level the players are, the longer the game lasts, and vice versa. After the challengers win their first point, the next game starts, and again, there are two possible events to be scheduled. Either kings win with a probability of 50% and the game restarts immediately, or the challengers win their second point and become the new kings, thus restarting the game with those two new kings in place. Similar to Start 1, Start 2 follows the same procedure. The difference is that now we will count the number of games a certain pair of kings plays. When the count gets to 3, the current kings switch places with the additional kings added at the beginning of the trial, and the game restarts with the additional pair playing as kings.